coordinate sequential motor activities initiated by the cerebral cortex. You can see. Now let's talk about the functional unit of cerebellar cortex, the Purkinje cell and deep nuclear cell. Now you should be knowing about the functional unit of cerebral cortex, cerebellar cortex. Now the three layers they are being, the first is the molecular layer, then Purkinje cell layer, then the granule cell layer. Deep cerebellar nuclei send output signals to the other parts of the nervous system. The neuronal circuit is repeated 30 million times. Output from the functional unit is from a deep nuclear cell. This cell is continually under excitatory and inhibitory influences. The excitatory influences arise from direct connections with afferent fibers that enter the cerebellum from the brain or the periphery. The inhibitory influence arises entirely from the Purkinje cell in the cortex of the cerebellum. The afferent inputs to the cerebellum are mainly of two types, the climbing fiber type and the MOSSY fiber type. You can see the neuronal circuit of a functional unit of cerebellar cortex. The cerebellar cortex having three layers, the molecular layer, Purkinje cell layer, the granule cell layer, and then to the deep nuclei. Now the climbing fibers and MOSSY fibers. Climbing fibers. The climbing fibers all originate from the inferior olives of the medulla. There is one climbing fiber for about 5 to 10 Purkinje cells. The climbing fiber branches to deep nuclear cells, outer layers of cerebellar cortex, make 300 synapses with the soma and dendrites of each Purkinje cell. A single impulse, prolonged up to 1 second, peculiar type of action potential in each Purkinje cell, beginning with a strong spike and followed by a trail of weakening secondary spikes. This action potential is called the complex spike. Now, what are the MOSSY fibers? There is presence of multiple sources. They are from higher brain, brainstem, and the spinal cord. They send collaterals to excite the deep nuclear cells. They go to granule cells, synapse for 100 to 1000 granule cells. Granule cells, axons to molecular cells, branches parallel to folia, 500 to 1000 granule cells for each Purkinje cell, synapse with 80,000 to 200,000 parallel fibers. The MOSSY fiber input to the Purkinje cell have weak synaptic connections, so large number of MOSSY fibers must be stimulated simultaneously to excite the Purkinje cell. Activation usually is a much weaker short duration Purkinje cell action potential, a simple spike, rather than the prolonged complex action potential caused by the climbing fiber input. Now let's talk about cerebellar cortex. It has the afferents, it has the efferents. Now the afferents, they are the MOSSY fibers, the climbing fibers. The efferents, they are the axons of Purkinje cells. Granule cells are excitatory, releasing the glutamate, and the stellate cells, the basket cells, Golgi cells, Purkinje cells, they are all inhibitory, releasing to gamma aminobutyric acid neurotransmitter. Again, the neuronal circuit of a functional unit of the cerebellar cortex. You can see the MOSSY fibers, the climbing fibers, they are the afferents, and then the presence of granule cells, Purkinje cells, and the parallel fibers. Purkinje cells and deep nuclear cells, they fire continuously under normal resting conditions. Purkinje cells and deep nuclear cells, they normally fire continuously. The Purkinje cell fires at 50 to 100 action potentials per second. The deep nuclear cells, they fire at much higher rates. The balance between excitation and inhibition at the deep cerebellar nuclei are there. Climbing and MOSSY fibers stimulate them. Signals from the Purkinje cells inhibit them. The balance is there between these two effects is slight excitation. Output from the deep nuclear cell remains at a moderate level of continuous stimulation. Now, what is the difference between the climbing and MOSSY fibers? They have the origin from the inferior olives of medulla. They are having origin from all other fibers of motor system. Olivocerebellar tract makes 300 synaptic contact with dendrites of Purkinje cell. Cerebellar afferent tracts the synapse with 100 to 1000 granule cells. A climbing fiber makes contact with 5 to 10 Purkinje cells. They exert strong excitatory effects on single Purkinje cells. A single MOSSY fibers may stimulate thousands of Purkinje cells. Action potential is showing the complex spikes, but over here the action potential is having simple spikes. There is first a rapid excitatory signal sent by deep nuclear cells. Motor output pathway to enhance the motor movement, followed within another small fraction of a second by an inhibitory signal. This inhibitory signal resembles a delay line negative feedback signal that is effective in providing damping. When the motor system is excited, a negative feedback signal occurs after a short delay to stop the muscle movement from overshooting its mark. Otherwise, oscillation, jerky movement would occur. Other inhibitory cells in the cerebellum. In addition to the deep nuclear cells, granule cells, and Purkinje cells, there are two other types of neurons in the cerebellum. They are basket cells and stellate cells. Now, stellate cells are inhibitory cells with short axons. These cells are located in the molecular layer of the cerebellar cortex, lying among and stimulated by the small parallel fibers. Now, these cells send their axons at right angles across the parallel fibers, and they cause the lateral inhibition of adjacent Purkinje cells, so sharpening the signal as a result. Now we should know about the turn on, turn off, and vice versa. The typical function of cerebellum is to help to provide the rapid turn-on signals for the agonist muscles and simultaneous reciprocal turn-off signals for the antagonist muscles at the onset of a movement. Then on approaching termination of the movement, the cerebellum is mainly responsible for timing and executing the turn-off signals to the agonists and turn-on signals to the antagonists. Contraction at the onset of movement begins with signals from the cerebral cortex pass through brainstem and quad pathways to the agonist muscles. At the same time, the parallel signals are sent by way of the pontile MOSSY fibers into the cerebellum. One branch of each MOSSY fiber goes directly to deep nuclear cells, instantly sending an excitatory signal back into the cerebral corticospinal motor system. So the turn-on signal becomes more powerful because it becomes the sum of both the cortical and the cerebellar signals. All MOSSY fibers have a second branch that transmits signals by way of the granule cells to the cerebellar cortex and by way of parallel fibers to the Purkinje cells. The Purkinje cells in turn inhibit the deep nuclear cells. They help to turn off the movement after a short time. Throughout the spinal cord, there are reciprocal agonist-antagonist circuits for virtually every movement that the cord can initiate. Plus, inhibitory cells play roles in the initial inhibition of the antagonist muscles at onset of a movement and subsequent excitation at the end of a movement. Now we should be knowing about the white matter of cerebellum. It is formed by afferent and efferent nerve fibers. These are classified into three groups: projection fibers, association fibers, commissural fibers. Now projection fibers. These fibers, they connect the cerebellum with the other part of central nervous system. Association fibers, they connect different regions of the same cerebellum hemisphere. Commissural fibers, they connect the areas of both halves of the cerebellar cortex. The efferent and afferent fibers are arranged in three bundles: inferior cerebellar peduncle between cerebellum and medulla, middle cerebellar peduncle between cerebellum and pons, superior cerebellar peduncle between cerebellum and midbrain. Now the Purkinje cells learn. When a person first performs a new motor act, the degree of motor enhancement by the cerebellum at the onset of contraction, the degree of inhibition at the end of contraction, and the timing of these are almost always incorrect for accurate performance of the movement. But after the act has been performed many times, the individual events, they become progressively more accurate. Sometimes requiring only a few movements before the desired result is achieved. Now functional division. Now what is the functional division of cerebellum? The nervous system uses the cerebellum to coordinate the motor control functions at three levels. They are at the vestibulocerebellum, spinocerebellum, and corticocerebellum. Now functions of the cerebellum. They are frequent